Do you ever wonder how light bulbs do not flash or fluctuate and remain constant for a long period of time? Well, it's because of capacitors, a so-called device that stores electrical energy inside the light bulb. Capacitor's main role is to store electrostatic energy in an electric field and release it when the circuit requires it. It also maintains the voltage low enough to prevent explosions and unnecessary accidents. Now that we have a background of what capacitors are, we will now find the capacity of its storage. This storage is known as equivalent capacitance. Knowing its equivalent capacitance can help us identify up to what voltage it can manage to control to prevent an explosion. For example, if a battery is attached to 4 capacitors, we must find its equivalent capacitance. According to the rules of capacitors, we can see that C2 and C3 are parallel, which means they have the same charge, and therefore, we can simply add C2 and C3. So 200 microfarads plus 125 microfarads gives us 325 microfarads. We can now write it like this. And look, the sum of C2 and C3 have the same value of 325 microfarads to C4. According to the rules of the capacitors in series, when two capacitors have the same value, we will multiply the value to 1/2, which gives us the value of 162.5 microfarads. Look at C1. It is also 162.5 microfarads. Again, according to the rules, we will multiply the value to 1/2, which now gives us the equivalent capacitance of 81.25 microfarads. Now, it's time to calculate the charge with the formula charge is equal to equivalent capacitance times volt. In our problem, the given value of volts is 100%. So, we will multiply 81.75 microfarads to 100 volts, which gives us 8,125 microcoulombs. This means that all capacitors C1 to C4 have 8,125 microcoulombs as their charge. If you remember, we combined C2 and C3 for they have the same charge. But how about their individual charge? To calculate the charge of C2, we will use the formula total charge multiplied to C2 over C2 plus C3. Now, if we will substitute the value, it will be now 8,125 microcoulombs times 200 microfarads over 325 microfarads. Therefore, the individual charge of C2 is 500 microcoulombs. From this, we will derive the formula to obtain the individual charge of C3. Substituting the values to the formula, it will give us 325 microcoulombs. This is now the individual charge of C3. To sum up, there are many ways to apply mathematics in real life. In this video, we showed how differential calculus plays an important role in electronics.